We searched the solar system for life. We looked at Mars. We studied Venus. We explored the outer planets and their moons. And everywhere we went, we found silence. No forests, no oceans filled with life, no living systems, except one place, a world that should not be special, but is. This is Earth. Earth orbits at a specific distance from the Sun. Not too close, not too far. This region is known as the habitable zone. Here, temperatures allow liquid water to exist on the surface. Water is essential, not just for life as we know it, but for chemical complexity itself. Too close to the Sun and water evaporates. Too far and it freezes. Earth exists in a narrow range where water remains stable. This is not guaranteed. It is a condition, a requirement, and Earth meets it. Earth's atmosphere is not just air. It is a system. It regulates temperature. It protects from radiation. It enables breathing. The composition is precise. Nitrogen, oxygen, trace gases. Oxygen, in particular, is produced by life itself, plants and microorganisms. Without them, oxygen levels would collapse. The atmosphere also contains an ozone layer. This layer absorbs harmful ultraviolet radiation from the sun. Without it, life on the surface would be exposed to lethal energy. Earth's atmosphere is not static. It is maintained, balanced, driven by life and geology together. Earth is a water world. Oceans cover more than 70% of its surface. But water does not remain still. It moves, evaporates into the atmosphere, condenses into clouds, falls as rain, flows across land. This cycle distributes energy, regulates temperature, supports ecosystems. Water connects everything, from oceans to atmosphere to land. No other planet in the solar system has this active, stable cycle on the surface. Mars had water, but lost it. Venus may have had water, but lost it. Earth kept it. Earth is not just habitable, it is stable. Over billions of years, it has maintained conditions suitable for life. This stability comes from feedback systems. For example, carbon dioxide in the atmosphere regulates temperature. Too much warming, too little cooling. Geological processes balance this. Volcanoes release gases. Oceans absorb carbon. Rocks store it. This is a long-term regulation system, a planetary scale balance. Without it, Earth could become unstable, like Venus or Mars, but it didn't. Earth is not perfect. It is balanced. Earth exists in a hostile environment. Radiation from the sun, charged particles from deep space. Without protection, the atmosphere would be stripped away. Water would be lost. Life would not survive. Earth's protection comes from its magnetic field, generated deep within the planet. At the core, liquid iron moves. This motion creates electrical currents. These currents generate a magnetic field. This field extends far into space, forming the magnetosphere. When solar wind reaches Earth, it is deflected, guided around the planet. Only a small fraction reaches the poles, creating auroras. Without this shield, Earth might resemble Mars, a planet that lost its atmosphere, a world exposed. Earth is protected. Earth's moon is not just a satellite. It stabilizes the planet. Without the moon, Earth's axial tilt could vary dramatically. This would cause extreme climate shifts, unstable seasons, rapid environmental change. The moon's gravity keeps Earth's tilt relatively constant, around 23.5 degrees. This stability allows predictable seasons, long-term climate balance. The moon also affects tides. Ocean tides create movement. circulation, energy distribution. Some theories suggest tides may have played a role in the origin of life, by creating environments where chemistry could evolve. The moon is not just nearby. It is part of Earth's system. Earth's surface is not fixed. It moves. Continents shift. Oceans open and close. This is plate tectonics. Large sections of Earth's crust move slowly over time, driven by heat from the interior. This movement recycles material. Carbon is stored in rocks, released through volcanoes, absorbed by oceans. This cycle regulates the atmosphere. Without plate tectonics, this balance would break. Carbon dioxide would accumulate or disappear. Either case could destabilize climate. Mars does not have active plate tectonics. Venus shows limited evidence. Earth does, and it changes everything. Life does not appear instantly. It requires time, stable conditions over long periods. Earth has provided that stability for billions of years. Conditions have changed. Ice ages, warm periods, but the system remained within limits. Not too extreme, not too unstable. This allowed life to evolve, from simple organisms to complex systems. On other planets, conditions changed too quickly, or too dramatically. Mars lost its atmosphere. Venus became too hot. Earth remained within range, not by chance alone, but through interacting systems, working together, maintaining balance. Earth is not the only planet that could have supported life. Mars once had water, rivers, lakes, but it lost its atmosphere. Solar wind stripped it away. Water disappeared. The planet became cold and dry. Venus may have had oceans, but it underwent a runaway greenhouse effect. Heat increased. Water evaporated. The atmosphere thickened. Surface temperatures became extreme. These planets did not start as dead worlds. They became them. Earth did not. The difference is not a single factor. It is a combination, a balance. Mars lost protection. Venus lost control. Earth maintained both. Beyond the solar system, thousands of planets have been discovered. Exoplanets. Some are similar in size to Earth. Some orbit within habitable zones. But distance limits what we can observe. We cannot see oceans directly. We cannot confirm life. Instead, we analyze atmospheres. Light passing through a planet's atmosphere carries information, chemical signatures, possible indicators of life, oxygen, methane. But interpretation is complex. These signals can have non-biological sources. We are searching, but we have not confirmed. Not yet. On Earth, life exists in extreme environments, deep ocean vents, frozen regions, acidic lakes. This expands our understanding of habitability. Life is adaptable, but it still requires certain conditions: energy, liquid medium, stable chemistry. Without these, life cannot persist. Other planets may meet some of these conditions, but not all. Europa may have water. Enceladus may have energy, but we do not yet know if life exists there. Earth remains the only confirmed example. All of our understanding of life comes from one planet, Earth. We have one data point, one example. This limits our conclusions. We know life can exist, but we do not know how common it is, or how rare. Earth may be typical, or unique. We do not yet know, but we continue to measure, to observe, to search, because the question is not just scientific. It is fundamental. Are we alone? So far, the answer is unknown.